Here's an example where using critical points can definitely give you an advantage in graphing a trig function. Let's graph y equals sine of pi times x. Now, we know that the period is 2 pi divided by b, or in this case pi, so the period of this function is regular 2. Now, this is not a denomination of pi, so it's not going to be easy for us to look at a graph and maybe visually transfer points. But we think if we want to capture one period in 2, perhaps it would be judicious to label our graph in regular number line numbers as opposed to denominations of pi. Now sine of 0 is just 0. And I know that in the course of going 2 along the number line, my sine function needs to go up, come down across the x-axis, bottom out at -1, and come back up to the x-axis. And I know that one of these things has to happen every 1/2 because all of it has to fit in 2, and there's 4 critical points there, and they're evenly spaced. So I know that the pattern goes 0, 1, 0, -1, 0, and I can put those points on my graph and then connect them, confidently knowing that I have a good, accurate representation of the sine of pi x here. Now, it was just my decision to label the x-axis in this manner. So the advantage to critical points can be when you know what the function should look like, but you don't have the exact same scales set up as you would have had if you had denominations of pi and could have easily sketched the parent function. It would be kind of difficult to sketch the parent function here. All I know is that pi halves falls somewhere beyond 1, but less than 2, and I know that pi is about 3.14. So if I added a parent function, it wouldn't be incredibly useful in the grand scheme of attempting to graph this particular function.